All right, folks, we are recording. Good morning, good evening, good afternoon, everyone, from wherever you're joining in. My name is Prithvi Raj. I am your host for today, and we are hosting the Chaos Engineering Meetup with our amazing speaker for today, Caleb Zhu. We were supposed to have Dharmesh as well from Google joining us, but unfortunately, he has met with an unfortunate incident because of which he might not be able to join us. But we still have an amazing agenda up our sleeves with Caleb talking about how they build capabilities around chaos engineering at HCL and how they got started with the practice of chaos engineering and how they are practicing chaos engineering at HCL with LitmusChaos. So before I hand it over to Caleb, maybe we can just introduce him and talk about Caleb a little. He's been a software engineer in the platforms team at HCL Software based out of North Carolina, USA, and he helps prototype and collaborate on cloud native chaos practices. He's been working on cloud native technologies from some time now, and he's also been an amazing LitmusChaos community member. So again, once again, we are glad to have him here. And without any further ado, I'll just share my screen to share the agenda in hand and then hand it over to Caleb. So let me share the agenda with all of you. So if you can see my screen, you can see Caleb will be talking about how they improved application and platform resilience with chaos engineering using LitmusChaos at HCL. And they'll just discuss how the practice came up, how the journey has been, and I'll further allow Caleb to take it forward. So and once again, thanks a lot, folks, for joining in. Feel free to ask your questions in chat, and we'll have a Q&A at the end of the meetup. It's going to be a short meetup, a 30-minute meetup. So post the meetup, feel free to ask your questions. And once again, those who are joining in new, feel free to join the LitmusChaos Slack. I'll be sharing the link to the Slack during this call so that you can ask your follow-up questions and be a part of this community. So thank you, folks, once again. Caleb, the floor is all yours.
Thanks, Prithvi. I really appreciate the chance to share with everyone. So I will go ahead and share my screen. So I hope you all can see my presentation. Yeah, so today I'm going to be talking about how we improve application and platform resilience here at HCL Software, with which Litmus has been a big tool in that journey for us so far. Yeah. So first, I'll just talk a bit about who we are and what we do, just so you have some context about how we're using Litmus. Yeah, so I'm part of the HCL Sophie team, which is short for Solution Factory. And so what we do really is we kind of provide cloud native packaging and deployment solutions for a bunch of the products in the HCL software portfolio. So these are really mature products in their respective spaces, but we're kind of bringing them into the cloud native space. And part of that is also showcasing how these software products solve real life business problems. And so the Sophie team, we have we have a software catalog kind of that you can see in the screenshot, where we allow users they can download Helm charts to deploy their products that they own. And also you can see there's also those launch it buttons. We provide kind of a demo sandbox space to be able to try the products or certain configurations of them that simulate real life scenarios. So that's kind of just the background about what we do. And so today I wanted to present two case studies about how we've been using Litmus at HCL to support these business goals that I just mentioned. So the first case study that I wanted to mention is how we are using Litmus to simulate GKE node pool scale downs. And so this I hope this flowchart helps everyone understand, especially if you're new to chaos engineering or Litmus, how you get from kind of a business objective to chaos engineering. So in this case, we wanted to be able to scale our node pools down to 0 and scale down the applications that are running there when they're not in use, because frankly, Kubernetes clusters are pretty expensive. And so we want to be able to reduce operational cost. And so that leads to a question, right? Will the application and infrastructure, will they continue to operate as expected once we scale them down and bring them back up when we want to use it again? Will it still be usable? Will it still be in a consistent state that we would expect? And so that's where Litmus comes in handy to run these experiments, right? Being able to simulate and automate this test scenario. And so, yeah, you can see from the experiment, we take those results, and that gives us feedback that we can take to the platform and infrastructure team that we have, and also the application and product teams that we test our products with. And you can see from, after we give them feedback, they also iterate upon it. And so it turns from kind of the first top half is like a discovery process. Chaos engineering is a lot of discovery about things that you didn't know about your system. And then it becomes a test process, right? That feedback loop those feedback loops you see in the bottom, it becomes something you can assert upon and say, this is the desired state to be. So it's discovery, and then you can build upon that to create resilience. That's kind of a high level summary. Yeah, so just to go a bit more in depth, so this was an experiment that wasn't provided out of the box by the existing LitmusChaos library that is open source. So for this experiment, we actually built off of the existing Litmus SDK. With this, it's written in Golang, so we created a custom experiment runner image and use that with our chaos experiments. And the benefit here is that we can use the GCP client library for Golang to automate the actual operations of scaling node pools up and down and watching these node pools be provisioned and poured down. And then we can hook into the existing functionality provided by Litmus SDK for authentication, for probes, reporting, monitoring, logging. Yeah, so for instance, everything in blue here, all the blue boxes are the parts that we wrote kind of with the Golang GCP library. And then the yellow and the orange pieces are the parts provided by the Litmus SDK, so long as we provide the proper integrations with those pieces. So you get all of the benefits of the Litmus SDK framework about visibility and reporting, but of course the actual business and application logic is custom. Yeah. And so from this, we, scaling up and down the node pools, we did find some discoveries. We found that when those nodes are coming back up, outbound DNS queries may initially fail for a little bit. And we investigated further. DNS is provided by the kube DNS service, a set of pods in the kube system namespace for that routes DNS traffic for destinations both inside and outside the cluster. And it takes some time for those pods to get ready. And so on top of that, we found that some of our applications, they perform outbound network calls when they start up, and that requires DNS to be there. And moreover, we found that when those calls fail, the applications, they actually enter a state that requires manual intervention for them to be able to start up properly again. And so you can see, yeah, one of the first thing is something that we brought up with our platform team and said, hey, this is something that, if we could, when we're scaling down and up, if we can isolate those system pods onto a separate node pool, right? Those can be, if we can bring that up a little earlier, give them time to get ready before we do other stuff, that can help us reduce the outage for the actual application. And then we also went to our application team and the team that was making this application and said, hey, maybe this is something you can look into for your application startup process. You can't just assume that you have outbound network connectivity when you start. And so just in general, this brought up, this challenged some of our assumptions, right? You would think that when Kubernetes schedules a pod onto a node, that everything is ready to go. Network is ready, disk is ready, everything's ready. But as we found out this time, just because a node accepts a pod for scheduling, for starting, doesn't mean that it's completely ready. And so in this way, it kind of uncovered that false assumption and gave us ways it showed ways that we can work around that assumption and then continue to test and make sure that our understanding is correct. So that's kind of what we discovered out of that. Yeah, so that was the first case study. And of course, if there's any questions, I'll be happy to take them at the end during the question time. But I also wanted to jump into our second case study, which is custom node restart chaos. And so just like last one, it came out of a business motivation. This one comes out of the fact that sometimes cloud providers will automatically restart your nodes in your cluster when they enter an unhealthy state. So it's part of their auto repair process. And we've found that operationally, we've also had to manually restart nodes sometimes when they enter an unhealthy state for various reasons. And that helps to bring them back to normal. And so the question was, can our applications withstand that, right? When there's the ones that are running on those nodes, can they withstand that kind of interruption? Yeah. And so this is kind of what we came up with. It's a little bit complicated. But to give some context, Litmus does already have a node restart chaos experiment out of the box, and we found it was really useful to understand their approach. But frankly, there were a couple of reasons that we couldn't just use that one directly. So the kind of things to take away from here are that while the existing experiment, it's designed that you need to have SSH access into the node that you want to restart, right? So that presents some authentication challenges. For instance, in GCP, we use GCP. So I or some service account would need to be able to have an SSH key assigned to a particular node, or all the nodes that we want to experiment with, and that involves adding a key, authorizing a key for a lot of different things. And so we wanted to work around that, or we wanted kind of a different authentication scheme to actually run that reboot. And so what we came up with is kind of a container-based way to do that. You can see that SSH bridge pod there. We put that on the node that we want to be able to restart. And it uses container namespace share, PID namespace sharing to be able to directly affect things on the node itself. So it's from inside the pod, we're actually able to restart that node. And of course, that bridge pod, as you can see, it is generating the SSH private key that the Litmus helper pod is using to actually run that command. And so that's one thing that we wanted to be able to resolve. That SSH private key you see there, it's generated on the fly and deleted after the experiment. So we don't have to manage the life cycle of that key beyond the experiment. And also we don't have to administer each individual node. The other aspect is also you see that placeholder unhealthy pod in the bottom right. What we found was that when our nodes are restarting, they will go down, but the status, the health status of the pods is still reported as running by the cluster, by the control plane. And it will remain that way for 1 or 2 minutes until the control plane seems to synchronize and realize, oh wait, that node has gone down, the pods are actually not running. And so with the existing experiment, we found that it starts doing the application health check immediately after issuing the command to restart before the node has actually had a chance to restart, and the pods still appear to be healthy. And so the experiment exits prematurely, thinking that the application is already healthy, when in fact it's just about to go down. So we added this placeholder unhealthy pod and kind of tricked Litmus into thinking that's part of the AUT. And so it's kind of tricky because we have to say that this is, this is part of the experiment. This is part of the application after we do the pre-chaos check, so that it thinks the application's ready for us to be able to start, but it has to be, that placeholder pod has to be there before we start checking after the chaos so that it doesn't end prematurely. And then of course, afterwards, we delete that pod as well. So we added that placeholder unhealthy pod basically to make sure that we accurately gauge the recovery process of the application. So yeah, the timing of that check and then the SSH credential management I mentioned before, those were kind of our big drivers for implementing something a little custom. Yeah. And I also wanted to talk about the takeaways that we got out of this. So most of this orchestration that you see here is happening with Argo workflows. So that's what Litmus uses to drive their the automation out of the box. And we found that we can extend it. We can extend the existing experiments through Argo workflows, right? So for instance, the creation of that SSH bridge pod, the creation of that placeholder pod, that was all orchestrated through Argo workflows. So we just took the existing experiment workflow and added steps to create those pods. And we add certain timing and synchronization things to make sure that those things run in the right order. But the point is they can be extended through Argo workflows to suit our specific needs. And also our team's familiarity with Argo workflows, we already use that for CI and some other things. So it made picking up this, this customization process, it made that a lot easier since we already had that knowledge and it transfers here. And we found that to be really helpful for customizing the framework and customizing the existing experiments. Yeah. So that's actually all I had to present today. Those were the 2 case studies. And I hope it helps to understanding, how you might adopt Litmus or how that it fits into like a business sense or your development cycle. But yeah, I'll open the time for any questions. And I guess we're a bit early, but yeah, feel free to ask away.
Caleb, we have a couple of questions in chat. You might want to take a look at them.
Sure, let me try to stop sharing real quick. Yeah, so I'll start with Josh's question about what other functionalities did you guys at HCL use alongside Litmus, which isn't available in the open source version. So far, we haven't had anything. I think that we've had to resort to finding something else. So, most of these additional things that we've had to figure out, like the GKE node pool scale down. So those kinds of things where the SDK doesn't cover it, we found that we can build it in-house and we can have it built to our spec basically. So yeah, so Litmus in itself has been kind of a good platform to build upon. And then of course, individual experiments, we do build it ourselves, but it's kind of built upon Litmus. So that's kind of in-house development that's happening there. Raj asked, is there a demo we have? Unfortunately, I don't have one that's prepared today. Yeah, but it really is just scaling up and down the GKE node pools clusters, and it works about as you would expect, I think. Did we add anything? Josh again asked, did we add anything for added security? Yeah, so there were a couple of things that we considered about the open source framework, Litmus itself. Part of the reasons that we chose Litmus was their status within CNCF. It was regarded well as there was a big process about them selecting and reviewing Litmus as a project. And so that was a big factor. And of course, we did perform reviews on any particular code that we were running, at least at a cursory level. We did consider some of the security concerns about operational risk, about security, about running Litmus in certain places. And so far it's been done in internal development environments for the most part, and there are efforts to bring it into production, but of course the ops team and the environments teams that run those production environments, they do their proper assessment from a permissions point of view, from a cluster security point of view for that. Matt also asked, for both of our case studies, did incidents, outages, downtime drive the reason why we ran these, or just awareness of how GKE works? Good question. Yeah, so for the first one, it was driven mostly by the desire for reducing operational costs, right? We want to be able to have the flexibility to scale things up and down. And we would expect that our customers that use these products also want that flexibility. And so that's something that we want to build into our products, that kind of resilience, right? That's part of what it means to be cloud native. You have that flexibility to run on whatever compute resources you have, including none, until you have resources that you want to give it. And so it's part of a feature. And for the second one, we did have incidents, outages, and downtime, right? So I mentioned that we had to manually restart some nodes. For instance, we had some issues with stale NFS mounts, leaving behind zombie processes on our nodes, and that can only be fixed by at least restarting your node. And so we want to make sure that our applications can actually withstand that kind of disruption if we have to do that manual intervention on our nodes. Yeah, Sunil asked Chaos implementation by using tools, requirement Chaos for Azure web apps and Azure function apps. Any suggestions? So personally, I don't think we have much experience with Azure web apps or function apps, but I do know there are some Azure Chaos experiments built into the toolkit. So you can try looking into those, exploring those if there's something that might suit your particular needs. Yeah, unfortunately, I don't have anything more specific than that. Yeah. Raj asked, how did we monitor different metrics during our after chaos? What observability tools are being used and what metrics are being monitored? So in my particular chaos, I think we were just monitoring, do all the pods come back? Are they able to recover? Are we able to get to an application homepage, right? So it's very basic kind of recovery testing. We do have other teams kind of in our organization that are going deeper with building application-specific probes using tools like JMeter and so other performance testing tools, probing tools, Grafana, Prometheus, to do more in-depth probing and quantitative results. And lastly, Raj also asked, when you extended Litmus, was it just Chaos Go Runner? Was other Litmus components also extended? Yeah, so for case one, we did mostly extending the Go Runner code itself. Of course, we have to write a custom experiment workflow YAML around that to wrap it. And then for the second case study, any other Litmus components also extended. Yeah, it was mostly just that workflow experiment YAML. That second one, we were using the existing Go Runner, didn't need any new Go Runner code for that. Yeah, thanks, Prithvi. Yeah, so a lot of those existing ones are already there. So I think for a lot of these use cases that people have asked about, that's a great starting point. Yeah. I think I got to the end of the questions that are in the chat. So yeah, thank you, Prithvi. Really appreciate this. Oh, one more question. Yeah, we have hybrid environment at our company, on-premise, AWS. Give some direction where to start chaos engineering. Yeah, so I think, so the tooling, Litmus can be deployed, on-premise and AWS. We also have some on-premise that we have teams working on deploying Litmus into. So I think the tooling is mostly the same. Litmus is pretty vendor neutral in terms of where it runs. But for where to start chaos engineering, I think it's important to discuss, with your product team or your product management team, your architects, and just understand what parts of the application are worth understanding more. Also, like operationally, what are some things that, what are some objectives? What are some common environmental things, or what are some common factors that you would expect to run into in your production environment? And I think starting from reality is a great way to decide what direction to go in terms of chaos engineering. Like for our 2 case studies, one was driven out of a business operational need, cost improvement, right, enhancement, and the other one is detecting resilience in response to an operational need to be able to restart the nodes. So in both of these cases, it starts with what are realistic scenarios that we need our application to be able to go through. And from there, you decide how to model it with the tools that you have. Yeah.
Thanks a lot, Caleb. I think those were a lot of questions and it was a quick session, but thank you so much for answering all the questions. If there are any other questions, maybe you can ask them now. I see one more coming up. So this is your last chance to ask any questions, and then perhaps we'll wind up.
Yeah, I'll answer this one from Ali. How different is it from Chaos Monkey? One thing I think Litmus does really well is it's cloud native focused, right? So chaos engineering as a practice has been around for a long time. Netflix brought it, came up with it a while ago. But it's been really important in cloud native space because just being distributed systems, there's so much complexity that we don't even see or realize is there. And so I think LitmusChaos is good because it integrates well with Kubernetes and cloud native out of the box. I feel that with Chaos Monkey or some other tooling, you'd have to build custom integrations and tooling to interact with Kubernetes and cloud native. So Litmus kind of gets you most of the way there already with the experiments out of the box. I think that's one big value add and advantage that Litmus has.
Thanks a lot, Caleb. Do we have any other questions? All right, folks, I see none. So with this, we come to the end of the Chaos Engineering Meetup today. It was a quick and a short one, but I hope you loved the session. I'm sharing the details for you to join the LitmusChaos Slack community, so that post this call as well, we stay connected and you can ask your questions. You can reach out to us, connect with us. And once again, folks, thank you so much for joining in, and we will be seeing you again next month, the last Saturday of the month. Till then, stay tuned. You can ask Caleb any questions on Slack, and feel free to reach out to us if you need any help with LitmusChaos or Chaos Engineering that way. Thank you so much once again, folks, for joining in, and hope you guys have a great day or a great evening ahead. Thanks, everyone.